Hello, good afternoon everyone. Here is Davide Taibi and I'm happy to present our paper on testing approach and tools for Lambda, AWS Lambda Serverless-Based applications. So in this work we investigated together with my colleagues Etu Rinta-Yaskari, Christopher Allen and Tamara Megla different approaches that can be applicable for serverless applications. And in particular, we implemented a set of tests for an existing application and we deployed them also as a GitHub project. So when testing a serverless application, the complexity is obviously way higher than testing the classical traditional monolithic systems. And the reasons are obviously that there are many moving parts, there is not so much control to what we are testing, in particular because we are not testing locally. We are not testing on our machines, but everything is run somewhere else. It's run on the cloud and we also don't have a clear control of where it is run. So we cannot access to the complete log files, we can access only to a limited set of information, and often companies test directly in production or they test locally with different approaches. The main problem that I think there is in testing serverless application is that there are no guidelines at the moment, or at least AWS provides a set of guidelines that are slightly different from those provided by Azure. And there are not examples or clear patterns or how we should test serverless-based applications. So in order to understand how to make this classical testing or how to test with the normal or with the most common approaches, we decided to try to understand how and which test approach are applicable in Lambda, so AWS Lambda serverless-based applications, and to identify also the tools that can be used in conjunction with testing process of AWS Lambda applications. So to run this study, we first of all develop a set of tests for an existing open source application. So we selected an application with certain criteria and the application was completely without tests, and we develop all the tests possible. And obviously those tests are also available on our GitHub repository so that everybody can also reuse it in future. We try to test the most common software testing techniques and we try to identify testing issues. So what did we test? We first of all selected the application we wanted to test, and we tested a cloud native program. We wanted a cloud native system with integration to other AWS services. So not just one single AWS Lambda function, but also the integration of other services such as DynamoDB, an API gateway, or other. We wanted something with at least a little complexity or enough complexity to write tests. So not something that was just a simple hello world, because that was not enough to run some meaningful tests. And something that was including a REST API, so a real REST API, so that it was possible to test also the API itself. And finally, obviously, a little of documentation available because we wanted to be sure to interpret appropriately the system in order to test it. So after a bit of screening, unfortunately, there were not so many applications available. I guess you're also aware about this problem. We searched for several applications, and what we found was the full stack application developed by the serverless framework. So this is a single page application, a simple page that is able to log or to register different type of users for different purposes. It is built with React, but from this point of view, I think we have no problem from the language. We are kind of language agnostic from the test point of view. And it is composed of different services, so it doesn't include only Lambda, as I was saying, but includes the API gateway that is queried with an API request, HTTP request. Then there is a Lambda function that is triggered through the API gateway and a DynamoDB that is used to save the data. And on the other side, there is also a front end with some static content that is distributed through the cloud front with the content delivery network, and it is saved in S3 bucket for the front end part. So you see a little bit more of complexity. Well, there is not just this single AWS Lambda function on the left, but there are several Lambda functions. This was just to show you the example of how it is structured. So about testing, this application doesn't have any test, even if it is widely used as example or as even a training example. There were no tests at all. So what we wanted to do was to develop a complete test suite to test all the possible functionalities of the application itself. And we tested with traditional methods. So we develop unit test, integration, and end-to-end test. So unit tests are the classical unit tests that you all know. So we develop unit tests for testing internally the code, but also to test APIs using unit test. Then we develop integration test in 3 levels. So first, it was the local integration test. So that means that we try to develop and deploy everything locally on our machines and to test directly the code on our local machines. We try to test hybridly, so that means something locally and something on cloud. And finally, we try to test the cloud integration test, so that means running the whole integrations directly on the cloud. And finally, the last is the end-to-end test, so testing directly the graphical user interface of the application or directly calling the application like the client would directly do. So we forked the application that I show in our GitHub repository, so you can also download, you can also find it. You can feel free to fork it and to make any comment to this application, or eventually to extend it also in the future. So what we found out. So this is first set of results. First, about tools for unit test. There are different tools available, and this is already a very interesting result. The first tool that we also selected is Jest, that is testing tools developed by Facebook. As alternative, there were other tools. There was Mocha, Chai for assertion, Sinon.js that was useful for doing mocking, and then Yasmin that is developed by Pivotal Labs. Yasmin is very complete, is also a very close competitor of Jest, while Mocha doesn't have all the different skill or features that has Jest and Yasmin. So our recommendation, if you need a complete unit test, is to use Jest or Yasmin from this point of view. About the methods, we tested the API, but the unit test for the, let's say, the backend API is not affected at all. I mean, you are testing normally. It doesn't matter if it is a serverless application or if it is not, because this is just what you can test also locally. We wanted to use to try black box test and white box test. So if you test as a black box an API, then you don't care if it is serverless or not. That's easy, you can just do it. If you want to test this as a white box, then you need to test locally. And to test locally, you need to mock something. So that means, mocking means that you need to replicate what a real object on cloud would do, so how the object might react. For example, if you want to run something that uses DynamoDB, so a database, then you need to have something that resembles DynamoDB or try to simulate the calls. What we use was Jest spy implementation. So Jest has a very cool feature where you can spy what functions are doing, so the different function calls in production, and then can replace the calls locally with mocks. So that means that whenever there is a request that resembles the same request that was received in production, then it just simulates the same request and returns the same result. So it's like creating a fake result that very, very closely resembles the real response that you might obtain in production. And this is really good because then in this way you can simulate what might happen. Obviously, it doesn't work in every context. You can obviously, of course, test or add extra features or extra logic on top of that. Still, it is not very easy. Something is not easily mockable, and in particular, DynamoDB is not always 100% compatible. Then The other possibility for other components, exactly like DynamoDB, is to use the AWS SDK mock for mocking. So this SDK enables to mock different components from AWS, such as this and DynamoDB. But it is important to remember that AWS does not guarantee the complete or the identical functioning of the mocking, this AWS SDK mocking, and the system running in production. So it might resemble, but it's not identical and it's not the same. This is a problem that unfortunately in some cases might create some issues. The local integration test was run completely on the cloud. So not locally anymore, but on cloud. So the tests are executed on the cloud. The problem when you execute there the test is that you don't have access to the complete function runtime. You might have other issues like the cold start in case you're interested to good response time. And the other issues is that sometimes it might be very expensive to have an identical copy of the system in production. And some developers also reported that they are testing directly on the system in production. So this might also affect or impact in some way the real system in production. So imagine if running a test would crash the whole system. So the recommendation is to have a clone of the system for doing the test and then move the changes directly to the production system. But we know that some people are directly testing in production because of cost reasons, because of time reasons, because of different pressures. There are some alternative options for integration, not only the one that we adopted. So one is to test REST API with like Postman or other tools for testing REST API. But this is again testing in black box, not in white box. We can call directly the functions, so the Lambda functions, using the CLI, so Command Line Interface. We can use the Pulumi framework, that is another framework that can be used for this approach. And we also try to use Pulumi in our system. Finally, end-to-end test. So end-to-end replicate exactly what the end user of your system would do on the system itself. So if the end user is a human with a graphical interface, then the end-to-end test is simply clicking on the same buttons or functions that the end user might click. So there are different options. And as for tools, we selected the Cypress framework. So the Cypress framework is based on Selenium. That is probably the most common most common tool for end-to-end test. And the very good advance of Cypress framework is that it can run on a browser, so it doesn't need another specific application, and it's very easy and fast to see. You can run some baked tasks, so you can prepare some tasks and run it also in the second stage. And then you can run also tests iteratively. So depending on the results of one test, you can run another one, or you can go even with much more complexity. There are other options, of course. There are Selenium WebDriver, but it requires a standalone app. It's way more complex compared to Cypress Framework. There are other two, Nightwatch.js and WebDriver.io, but we found them pretty complex to use. And in the end, the guys decided to implement it with the Cypress Framework because of complexity reasons. And this also shows that the complexity of running these tools sometimes is relatively high. Obviously depends on the skills of the developers, obviously depends also on the type of company and on the type of application, so we cannot definitely generalize about this part. So just to summarize all the different approaches, I'd like just to stress the advantage and disadvantage of what we found. So when we test unit, when we run unit test, we run it with Jest. Advantages were a lot. I mean, the classical advantages of running a unit test. So it was possible to test that part. The problem of the running unit test, it was exactly about mocking, and that it takes a lot of time and resources to run all the single unit. So this is might be a problem in some context. The local integration, when we talk about integration, for the local for all of them we use Jest, but for the local Jest only, and Jest is really fast and very easy to integrate. Disadvantage is again that you need to mock, and mocking is really complex. When we talk about hybrid integration, the advantage is that you don't need to mock. That's the big advantage and the reason why you want to use hybrid integration. But you need to rely on the cloud, on something that is not completely under your control. But honestly, from my point of view, I wouldn't bother that much, especially because your application is running there. It is running on that cloud. So you should trust in a certain way, and you should also try to test the application directly on cloud to see how it reacts. Cloud integration is the last type of integration where we use Jest and Pulumi. The advantage is that you test it on real world, so it's not mocking application, it's not something that is part of locally, part directly on the cloud. You really test what's there. And the problem is that to have a very high coverage is not that easy. Sometimes it's very expensive to have very good coverage of all the functions and especially all the branches. And well, I would say lack of mocking, it might consider an advantage or a disadvantage. Let's say from certain point of view is a disadvantage because you may want to have something that replies always in the same way, so something deterministic. But sometimes it's also an advantage because you are testing with a real system without needing a mocking. So this is something in between. Finally, end-to-end test, we use Cypress and Pulumi. Well, advantages are the classical, that you can test directly the whole application at once. The problem is that it's hard to have consistency, especially if you test in production, and it's very hard to have replicability. If you have different data, you might have different results, and this was the main issue that we found. So in conclusion, we can confirm that testing application is obviously still more complex than monolithic systems. There are some tools, but the problem is that they change very often, and several times they also became not compatible. It was nice to see that we started like 1 year ago with the system, to implementation of this system, and this was implemented by some master students. They took some months to implement, and during the implementation the tool was not the new version of the tools was not compatible anymore with the previous version of the tools. And well, while this might be acceptable for a master thesis, this is probably not really acceptable in a company, especially when you just spent a lot of money to implement a system that then need to be partially re-implemented or readapted just to make it compliant with the new version of the tool. So we can say that tools are slowly getting mature because we're not anymore the beginning of serverless-based systems. So we have many more tools. Tools are working pretty well right now. Well, compared to a few years ago where the tools were often crashing and now they crash less frequently. Honestly, we have very few crashes of the testing tools compared to similar works that we performed a couple of years ago where the tools were crashing almost always. And something important to remember is that, unfortunately, we still need to run the test on the cloud. So it is not possible to replicate the whole system as is locally. Now, I don't know if this might be considered a benefit or a drawback. From certain point of view, I'd like to consider as a benefit because I like the idea of testing the system in production and to replicate exactly what the customer might see. But from another point of view, it might be obviously risky. So I guess you understand that point. So thanks a lot for the presentation. That was all for this work, and I'll be very happy to collaborate with any of you about testing tools or testing on serverless functions. We are progressing this work, and I mean, after the submission of this paper, we of course continue a lot to work on that, and soon we will be out with a literature review on testing tools and methods for serverless. But if any of you has some kind of idea or collaboration opportunity, I'll be very happy to work with my team with you. Thank you. Bye.